In the previous video, we talked much more about the registers with their types. And from the thumbnail, you would have come to know that what topics we are going to discuss in today's video. So let's jump off to the flags, stacks and heaps. In computer science, flag is a value that acts as a signal for a function or process. Let's understand this with the help of a code. Here, I marked a variable named as flag as false, and when the value of this num variable reaches a value of 100, flag is marked to true, whose effect is the result cannot exceed the number greater than 100. So, like this program, flags play such role at hardware level, which are registers and check for a particular program or instruction is successfully executed or not. Flags are generally binary flags, that is, they generally used to store the data in 0 or 1 form, which are nothing just a signal for the instruction to be executed. There are various types of flag, but we don't need to be worried around it. We will deal with them and understand their uses while reverse engineering. Stacks are considered to be the most important features of CPU, which saves temporary data in such a fashion that the elements stored in the last is retrieved first, and have an address register known as stack pointer register, which stores address of the topmost element of the stack. There are two most basic operations of the stack, which are push and pop. Push is for inserting data into stack and pop is for deletion. Now whenever any function is called in any program, there is a section of stack is reserved for the function known as stack frame. Let us look at these codes. We have two functions and we are not calling an unreachable function in the main. When you run this C program, it will print hello world and the stack of the program will look like this. But when we try to call the function which is called from the main function, then the stack will start looking like this. You can see that by placing the arguments on the stack frame for main has increased in size. We also reserved a space for return value, which is computed by addMe function, and when the function returns, the return value in the main gets restored and execution continues in the main until it finishes, and after that each data which is inside this stack gets popped out. Here, popping out of data without a permission is a major concern. So to deal with this, concept of heaps come in, which is used for storing the global variables. That is, the variables created on the heap are accessible by any function anywhere in your program. To allocate your data into heap, C language have built-in function as malloc or calloc, and after allocating, it's your responsibility to free it by using free function. If you don't do this step, then your program will have what is known as memory leak. That is, memory on the heap will still be set aside and would not be available to other processes that need it. So I think I have cleared the basics of stack, flag and heap, and I do not need to dig deep into this. We will learn more about them while doing reverse engineering. Till now, we have covered all the essentials for surviving into the war of reverse engineering. So from the next video onwards, we will get stronger day by day in the skills of reverse engineering by writing our own code and exploiting them. So that's all for today. Thanks for watching. Meet you soon. Until then, peace.